and joining. It is this other way. Here it is breakaway, and here it is coming together. So you can say that meeting at a point or breakaway, the angle can be found by plus or minus 180 degree. Now the angle of departure from an open loop pole is given by angle of departure from an open loop pole is given by angle of departure. Next problem. So angle of departure of but here it is normally when there is a complex pole or it is a complex conjugate poles are there, then this criteria use, but in our problem this is not required. Now the point of intersection of the root locus branches with the imaginary axis and the critical value of k can be determined by use of the Routh criterion. So that is the 8th point. So how you can find the point of intersection with the point of intersection with the imaginary axis? For that, so you have to take the same example here. So you have to form the characteristic equations, that is 1 plus g of s h of s is equal to 0. When you are making this plus 1 is equal to 0, you are getting an equations s3 plus 4s square plus 3s plus k is equal to 0. Now you have to form the Routh stability, Routh criterion that you already aware of the previous class. The maximum higher order is 3, so s raised to 3 to s raised to 0. So 1, 3, 4 k. Then you are making here 12 minus k divided by 4. 4 into 3, 12 minus k divided by 4. Remaining it is 0. Here it is k. So the condition for all the roots of the characteristic equations to the left of the imaginary axis, the following condition should be satisfied. All should be positive. So k should be, when you are analyzing, k should be greater than 0. Then 12 minus k by 4 should be greater than 0. When you are analyzing, k should be less than 12. Now critical value of k, which correspond to the location of roots on j omega axis, is given by 12 minus k by 4 is equal to 0, that is k is equal to 12. Now when this is becomes 0, what you need to do is you have to consider the auxiliary equations, that is 4s square plus 4s square plus k. Now k is 12, you substitute it. Now s square is minus 3, or s is equal to plus or minus j square root of 3, that you are getting like this. The alternate method, this already I explained. S square, there you have to substitute s as j omega. Then you have to equate the real and imaginary part. You will get the value of k as well as omega. So omega, so that is the meeting point. So here you will get the meeting point here is k is equal to 12 and omega is equal to root 3. Here k is again 12 and omega is equal to root 3. Okay, omega is equal to root 3. Now the root locus starts from both the poles. Then at breakaway point is at s is equal to 0.451. From there are asymptotes. So the direction it follows with asymptotes. So at infinity it may coincide like that, or otherwise it is almost parallel. Now you can see here also one asymptotes, so this will go to infinity, and third branch that start from -3, it will go to infinity. So this is the way of constructing the root locus. And here the ninth rule, the open loop gain k in pole 0 form at any point S0 on the root locus is given by product of k is the product of phasor length from S0 to open loop was product of phasor length from S0 to open loop zeros. So here yes, you can find here what is the value of k? What is the value of k here? So you can found this as product of length from poles to this. Here you already it is minus point magnitude yielding 0.451 into 1 minus 0.451 into 3 minus 0.451. So if you are multiplying these 3 points, if you are multiplying these 3 points, I think that you will get k at the meeting point. So this k value at this point can be calculated by the distance from poles to that point, this distance plus here to this distance. So the k value will be 0.631. I'm getting the point value is 0.631. So centroid, everything is asymptotes, everything is very clear. Almost all rule are satisfied.